Welcome back, guys. In this video, I'm going to try to give you a brief introduction to what would be the very next unit of study. We are kind of moving away from areas under curves and definite integrals to solving differential equations. I'm going to try to explain that real quickly in this video, and then there'll be a follow-up video that explains more in-depth differential equations that have a little more detail to them. So what is a differential equation? First of all, a differential equation is an equation that contains a derivative. That's pretty simple. For our purposes, they'll generally be given in the form dy dx equals whatever that function would be. Now, if you notice here, I gave you a first order differential equation. That basically means that this is the derivative. This is a first derivative equation. A second order differential equation will have a second derivative. For our purposes, we're going to be focusing on first order differential equations. That just basically means that we're only going to deal with first derivatives. If you plan on continuing your studies in math and engineering, you will see much harder, a whole class with much harder problems to solve. The class itself is called differential equations. Okay, so moving on. What does it mean to solve a differential equation? Well, when you solve regular equations, you try to isolate the y or isolate the x. Quadratics, you might factor, that kind of thing. But when we're solving a differential equation, what it really means is that you need to undo that derivative. You need to find the y function whose derivative is given. In other words, you're going to be doing the antiderivative. And there's two possibilities that could happen for this. You can either be asked to find a general solution, or you could be asked to find a specific solution. And here's the difference. The general solution would just be the antiderivative plus c, because you are basically finding all the possibilities, all the solutions that satisfy that equation. So all of the functions whose derivative is 3x squared plus 2x. And we need to represent that with a c. A specific solution, what's going to happen is they're going to give you the equation, but they're going to give you a point. And so that means, hey, I want the answer to this problem, but it has to be specifically the one that goes through the point 2, 10. I don't want all of them. I just want the curve with this solution. And so you address those in differently depending on what they ask. So we have general and then specific. I'm going to go over both of them in just a sec. Okay, so I have here my dy dx, and it says to find the general solution. Sometimes they won't even put general, they will just say solution. And I'm basically going to take the antiderivative. So the antiderivative of the derivative would give me y, and then I'll go ahead and work my power rule. I'll add 1, multiply by the reciprocal. That gives me x cubed plus x squared. So remember, you can just add 1 to the power, and the resulting power multiply the reciprocal, and that gets you there. Now, because it's a general solution at the end, I have to put plus c. And that's basically it. I take the antiderivative and put plus c. So that just means that I found the family of functions, all of them. This plus c could be plus 1, minus 1, 0, whatever the number is, and it will give me every single one. If I'm asked to find a specific solution, they will give me a point they want that solution to go through. So the process is the same. I take the antiderivative. So x cubed So here's my antiderivative, x cubed plus x squared plus c. Notice I still have a plus c. The difference is going to be now that I'm going to take this point, and since I know this is my x and this is my y, I'm going to go ahead and replace them into the function, and I'm going to solve for c. So I'm not going to have a plus c, I'm going to actually have plus some number. 10 is my y, so I'm going to put that in the y spot, and then I have 2 cubed plus 2 squared plus c. And I'm going to go ahead and solve for c. So 10 will equal 8 plus 4, which is 12. And I'll subtract 12 from both sides. So that tells me that negative 2 equals c. And so now I have to go back and replace that c. So I can just erase the c with whatever it came out to be. Which in this case will be negative 2. Okay, and so that's my answer. And the difference, again, a general solution is going to have a plus c. And a specific solution, you're actually going to go in, replace the x and the y, find your c, and then come back in. The actual equation is your answer. In the next video, you're going to see ones that are a little bit more intricate. They have more detail because they have discontinuities. But hopefully this gave you a good idea of what a differential equation is and how to solve it. Awesome. Let me know if you have questions.